All right, we got adding and subtracting rational expressions today. We're gonna look at three different types. We're gonna start off pretty nice with a monomial denominator, move to when we have a polynomial denominator and we have to actually factor. And then we're gonna look at this ugly thing here where we have adding rational expressions top and bottom of a fraction, and then we're trying to divide. We'll build on it, it'll be fine. And in all honesty, this is my second time doing the video because I screwed it up the first time. Don't judge. All right, when I look at this first one, adding or subtracting fractions, the very, very first thing we learn is you have to have common denominators. So that means we have to find the LCM. 6 and 4, there should be no struggle here, it's 12. If you think 24, you're finding the CM, not the LCM. Least, the lowest. So how do I make a 6 a 12? Well, I'm gonna have to multiply it by 2. How do I make a 4 a 12? I'm gonna have to multiply it by 3. Just in case you're thinking, oh, so you always multiply by the numerator? No, that was just a fluke. Now look at your variables. So everybody see we got x to the third and x squared. We need them to be the same. Well, all we need is for this x squared to get one more x, and then they will be the same. Or they'll meet up, or they'll have something, I don't know, in common. Least common multiple. So give this an x, and now we're the same. Look at your y's. This has 7, only has 1. Big difference. This needs 6 more, and now we agree. The nice thing here is we now have the exact same thing on both denominators, so let's multiply through and see what we're left with up top. My denominator on both sides is going to be a 12, x to the third, y to the sixth. I'm sorry, 7th. No, that was not a tally. I was just making sure you were listening. Top. All right, we're left with 9y to the sixth, I mean it this time, and a 4x squared. I'm adding, and some people look at this and go, oh, they don't combine. You're right, they don't. So write it as 9y to the sixth plus 4x squared, but because they have the same denominator, we can put it all over 12x to the third, y to the seventh. Now be careful, it's tempting. A lot of times you see this like, ooh, 12 and 9 can cancel. No, they can't. Because all of these terms cannot reduce by something. You can only cancel here if all of them have the same common thing to reduce by. Number 2, right off the bat, you got to factor. You have to be able to factor. So if I have a squared minus 2a minus 24, factors of c that add to b. The only things that multiply to negative 24 that add to negative 2 is a negative 6 and a positive 4. And when I look at my right side, G, C, F, they share a 6, which means I'm left with a plus 4. Okay, got to be able to do that pretty quickly. Let's take a pause before we go anywhere else, talk about excluded values. I have a lot of stuff in the denominator. I need to tell somebody what's not allowed. Never are you allowed a 0 in the denominator. So off to the side, I'm just going to state, hey, your a value can never equal 6 or negative 4. Notice both of those values would create zeros in the denominator and then the world would explode. Believe it. I've seen it. It's not pretty. So take the same mentality now that we saw with the other one. We have to have the exact same thing. Meaning, whatever they're missing, we have to give it to them so that they agree and can actually talk. I got an a minus 6 and an a plus 4. I got a 6 lone 6 and an a plus 4. Hopefully it's jumping out at you. This left side needs a lone 6. This right side needs an a minus 6. That will give everybody what they need, and now they're allowed to talk. They agree with each other. So at the top, I'm going to get an 18a plus 12. On the bottom, I know it's all that. This is called intelligent laziness. I know exactly what it'll be. I'll put it into my final answer. Minus 7a minus 42. Intelligent laziness. All right, time for my final answer. So first off, I'll actually write my denominator this time. I know I have 6, a plus 4, a minus 6. And now I'm just combining my like terms. But careful, you're subtracting. So 18a and 7a, those are the like terms. But I am subtracting 7a from 18a, which will leave me with 11a. Numbers, be very careful. You're still subtracting back here. So it's 12 minus negative 42. Minus negative, 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 positive. So you're adding them now, which will give us 54. Done. Once they have like denominators, you can combine like terms, and we have a single expression as our answer. Okay. Woo! Fat Daddy Nasty coming up. Last one, let's go. First off, think of it as a division problem. This is really 2 over x minus 3 plus 3x over, and let's factor that right now, make our lives easy. Difference of perfect squares. X plus 3, x minus 3. So we see that's really the top. And we're dividing by, because that's what a fraction represents, 3 over x plus 3 minus 4x over, again, factored form, x plus 3, x minus 3. That's really what's going on here. So breathe, and take top and bottom separate. Don't even try to do them both together first. Top and bottom, then we'll try to put them together. So when I look at this, who needs what? This side has everything it needs. It's not missing anything. This left side's like, ooh, I want that x plus 3. It looked really good. Can I have a bite? Yes, give it what it needs. And look how nice this is now. I'm left with 2x plus 6 over x plus 3, x minus 3, plus 3x over x plus 3, x minus 3. Now again, all of this is just getting ready for my top part. Combine like terms, you get a 5x plus 6 over x plus 3, x minus 3. Okay, we did it once, let's do it a second time. Now I'm going to look at the other side. Well, notice this is missing an x minus 3 this time, so give it what it needs. Top and bottom, x minus 3. We're still dividing this second quantity, but I'll now have a 3x minus 9, intelligent laziness, minus 4x, intelligent laziness. So I'm combining like terms. That's all I'm doing. I'm still dividing, but I will be left with, now watch, it's a negative. 3x minus 4x is a negative x, and there's nothing to combine with my negative 9. And the denominator is an x plus 3, x minus 3. Almost done, almost done. I'm so excited. Dividing by a fraction, you multiply by the reciprocal. So let's finish this off and make it pretty. The first one does not switch. We've got a 5x plus 6 over x plus 3, x minus 3, times the reciprocal, x plus 3, x minus 3, over negative x minus 9. Hello, Canceltown, USA. You see some nice stuff going here. Z. X plus 3 with the x plus 3, x minus 3, x minus 3. Tops, bottoms, what's left? Final answer. Final answer. We get a 5x plus 6 over negative x minus 9. Woo! Skills, baby. That's how it's done. 3 problems, real quick, on how to add and subtract rational expressions. Enjoy your 3-day weekend.